So this is a review of all the different functions that we've covered in pre-calculus. So our first one is our linear model, and that's our y equals mx plus b. And so again, we're just replacing the y with f of x. And so this is a growth at a constant rate, because our line will just go straight up, constant increase or constant decrease. So we're going to either get a positive slope or a negative slope. And the graph of this is a line, and its parent function is y equals x. So m is what's going to vertically stretch or compress it, and b is our shift up and down. Our next function is polynomials. So polynomials have whole number exponents here, like 0, 1, 2, 3, all the way to n. And our n is a non-negative integer. That's another way of just saying whole number. And a0, a1, an are called our coefficients. So coefficients. The degree of our polynomial is n. We also have some special polynomials. Quadratic, this is a degree 2. Just look at our exponent here. And its graph is a parabola. So that's that U-shaped one, upward or downward. And we use these often to do a model of a fall of an object. So like this. You can see that's a parabola there. It has that parabolic shape, or it could be launched up and then falling. Cubics, these have a degree 3. Again, we look at that exponent. And its graph is a cubic. It's got that S shape like this to it. But they can also have shapes that go like this, or they can have two critical points like that, or like this. But it's going to have that approaching from negative infinity and going up to positive infinity, or from positive infinity and then down to negative infinity. Okay, power functions. Power functions are x to some value up here, a, where a is a real number. So if a is equal to n, where n is a positive integer, then we get our basic polynomial functions we were dealing with before. We get our line, we get our parabola, we get our cubic, and then what happens with the degree 4 is it just kind of pancakes out, and I will discuss this more when we get into our parent functions and translations. And so x to the 5th looks just like the cube, but between -1 and 1, it kind of flattens out. I like to say it pancakes, because these are your fractions. And so what's happening is here is you think if you had a half to the 5th, this would be 1 over 2 to the power of 5. That's 1 over 32. We're at a third, you get 1 over 8. So it's just going to be a lot flatter here. It's going to be a much smaller fraction between 0 and 1 than it will be for 3. Same thing would happen with 4 compared to a parabola. So between -1 and 1, it's going to flatten down. So as n increases, the graph becomes compressed at the origin and stretched everywhere else. So you can see our parabola here is square, and as I make the exponent larger, you can see that in between -1 and 1, it is flattening. And everywhere else it's just getting more and more stretched. So if you look at this top point right here, as the exponent gets bigger, you can see it's getting like it's someone's pulling it. But what's happening in the middle is like someone's sitting on it. It's getting much, much more compressed. Because again, these are fractions and these are whole numbers, so they grow differently. So those are power functions. And like I said before, in other videos, we will go much more into it. This is just an introduction to the different types. All right. So a equals 1 over n. This is where n is a positive integers. What we are now getting is our root functions. So you're getting square roots, cube roots, fifth roots, and so on and so on. So this right here would be y equals x to the half, and this is y equals x to the 1/3. And so the graph of a square root we know looks like this, and the graph of a cube root looks just like the square root, but we also get to include the negatives, because over here this is where we get undefined non-real values, so they do not show up. Rational functions. This is f of x equals px over q of x. And this is where p of x and q of x are polynomials. This is also one that's a rational function. So if you do a to the negative 1, then you would get y equals x to the negative 1, which is 1 over x. That is also a rational function. And the domain of rational functions is where q of x does not equal 0. Remember, denominators cannot be 0. All right, and those are our basics. And now if we start putting them together, we get algebraic functions. So algebraic functions are constructed using algebraic operations. We use some of the above to create a function. So rational functions are also considered algebraic functions. So if we did something like this, x squared plus the square root of x, we call that f of x, that is an algebraic function. We've mixed our polynomial with our radical x. And if we do f of x equals square root of x over x squared plus 4, that's not a rational function anymore, even though it would be still considered an algebraic function. But we now have a root on the top. This is not a polynomial, but this is now an algebraic function. All right, we also have our trigonometric functions. We have our three basic, y equals sine x, y equals cosine x, and y equals tangent x. And if you remember graphing these, we have 4 quadrants that we deal with. These are circular functions. And so we go from 0, and we do 1, 2, 3, 4. Between 0 and 2 pi, those are our 4 marks. And now the domain of a sine function is from negative infinity to infinity, because we know this is going to go on forever and ever. It's our sinusoidal wave. The range, however, is from negative 1 to 1. If you remember our unit circle, we will go around the circle from negative 1 to 1, like this. So remember, our graph goes around the circle, so it goes from 0 to 1 to back to 0, back to 1. We're looking at the y coordinates, and that means our graph goes up to 1, down to negative 1, back up to 1, and so on. So it's got a range from negative 1 to positive 1. And then the period is 2 pi, because again, going around the circle is 2 pi. And so if our graph, we go up to 1, down to negative 1. So it goes from 0 up to 1, back down to 0, back down to negative 1, and back up to 0. Just like this. And then it repeats that same pattern. So the next point would be 1, 0, negative 1, 0, 1, 0. It's just going around our circle from 0 to 1 to 0 to negative 1. It is the y coordinate. And that's our graph. And again, it goes all the way from 0 to 2 pi. All right, cosine is very similar. It's from negative infinity to infinity. Remember, they're just co-functions. Its range is the same. And its period is exactly the same. But cosine on our unit circle is the 1, the x-coordinate. So it goes from 1 to 0 to negative 1 to 0 to 1 to 0 to negative 1 to 0. And so it's following this pattern. So it allows us to start at negative 1 instead of 0. So it's negative 1, 0, 1, 0, 1. So 1, 0, negative 1, 0, 1. And so we put a mark of 1 here and negative 1, and we go 1, 2, 3, 4, just like before. But we start at 1, and then 0, and then negative 1, and then 0, and then 1. And then we put that curve. Remember, all these are is basically the heights that we're getting from that function. So if you were to plug in 0, we'd have a y value of 1, right? And then if we plug in pi over 4, we would get rad 2 over 2, and so on and so on. Okay, now tangent. Tangent has our negative pi over 2 to pi over 2, because these are undefined values. If you remember the unit circle, as we go around, right here, this is when we have a x value of 0. And if you remember, tangent is y over x. So we're getting a denominator of 0. So at pi over 2, we have a denominator 0. It's undefined, undefined. And so tangent looks like this. It's going from that negative infinity all the way up to the positive infinity. The line I have drawn here is our tangent line. and it goes all the way up to positive infinity. So that is the graph of tangent, and then it just repeats over and over and over again throughout that, just like that. So tangent's period is pi because it goes from negative pi over 2 to pi over 2. So we know here at pi over 2 it's undefined. And if its period's pi, then we're going to get an undefined at pi over 2 plus pi k, where k is an integer. So every pi it's going to repeat. So pi units later we get another undefined, and then pi units later the same thing. And then right in the center, that's when it's 0, because that's when our y value is 0. And so our graph looks like this. It's going to always be down to the first asymptote and then up to the second. So it's down and so on. And then this repeats over and over and over again. So it's undefined when x is this. So x cannot equal pi over 2 plus pi k. All right, exponential functions. Exponential functions is when your variable is an exponent, and its domain is negative infinity to positive infinity because we have no issues with plugging anything into it. But its range has to be from 0 to infinity because there's no way to use an exponent to make a base 0. It's not going to happen. And so our graph looks like this. We have a horizontal asymptote, and our graph does this. And this is when b of x is positive, of course. When x is positive, if x is negative, then we get that decay motion. All right, domain then. So these are inverse functions. So the domain would now be from 0 to infinity. They switch, x and y switch. And its range is from negative infinity to infinity because they are inverses of each other, the exponential and the logarithmic function. So it looks very similar, just rotated. So instead of having a horizontal asymptote, we have a vertical. And it does that same growth. It goes from the negative, and then it grows up to the positive. All right, and that's everything. So now what I want you to do is hit pause and tell me which type of function we have here. Look at the previous functions and let me know. Okay, so you should have gotten exponential, power or polynomial, algebraic, and polynomial. And there you go. Thank you.